Welcome to this OW2 webinar, which will deal with the CLIF load testing platform today. So let me introduce you CLIF. CLIF, as I said, is an open source load testing platform, including load injectors for generating traffic on the system under test, and also it provides probes, which makes it possible to observe and measure the consumption of computing resources, either on the system under test or on the load injection part. So here is the public CLIF website on OW2 site. It's very easy to get all the documentation about CLIF. Just click here. You have a lot of user guides and advanced user developers documentation. You have some tutorials also. And very detailed documentation. Now to download, it's really easy too. The easiest way is just to get the binary ready to execute packages. So for example, here I'm using Windows in 64 bits, so I will choose this one. This is the latest version of CLIF, which has been released just yesterday, as you can see here. Or 2 days ago, sorry. So you just download this zip file from OW2, okay, and you click there and you're in. I'm not going to do it right now, but afterwards you just have to unzip this zip file wherever on your computer. The only thing that you have to check is that you have Java 6 or Java 7 runtime installed in your computer. Okay, so here it's okay for me. So once you have unzipped CLIF, you will find these files in this directory. What I'm going to show you here is the main user interface of CLIF, which we call the CLIF console, and it is based on the Eclipse Rich Client platform. So don't be surprised that you get here the Eclipse logo on this executable. Okay, I'm going to close all these files and all these projects, and I'm going to start a brand new project for this demonstration. Of course, when you will be running CLIF for the first time, you will have here an empty set of testing projects, but each time you will install a new version of CLIF, you will keep all your projects and they will still appear. Now I'm going to create a new CLIF test project. Okay. This test project will host all the test plans and scenarios for my load testing campaign. So what are we going to test today? I propose to test a simple website which is based on the DocuWiki middleware. So this is basically just like a web application. I'm going to build a simple test trying some links here and measure the response times. So let's go back to the Eclipse console, to the CLIF console, sorry. Here I'm going to create a new scenario. So I'm going in this wizard here to create a new Isaac scenario. The name Isaac is just a reference to this specific scenario definition environment that is integrated to CLIF. So just assume for the moment that we want to make just a unit load test. Just want to know the response time of the request with a minimal load. Okay, so I create this scenario. The first thing I have to do here is to import the plugins that will support the protocol, the load injection protocol. So I click on the Add button, and I see a lot of plugins. There are many of them, but the ones that I will be interested in right now is the HTTP injector, which supports the HTTP protocol for load injection. I give it a short name here. Okay, and I configure a special setting saying that when I will give a URL to load, I will also load recursively images and frames. Okay, what I will need also is something to emulate the user think time. And for this, I will take this particular plugin, constant timer. Okay, that I will set, and I will set this timer to a default value of 5 seconds, 5,000 milliseconds. I give it a pretty name, and it's fine. And now I just have to build my behavior, my virtual user behavior, which is basically a sequence of requests and think times. So I click here to add an instruction in my behavior, and I see that I have 6 lines here. The first 2 lines are about the plugins I have imported. So we find the HTTP plugin, and of course we find here all the specific methods, verbs that are supported to implement the HTTP protocol as a client, of course. So for instance, I can use a get method here. We find also other things underneath here, which are controls, which makes it possible to change the timeout. Okay, right now I'm just going to do an HTTP get. I click on this instruction, and now I have to give a number of parameters. Some of them are required, and others are optional. So the first required parameter, and I think finally it's the only one, required parameter is the URI. I'm going to pick it directly from my web browser here. Okay, so this is the link for the sitemap. So I will also, for convenience, when it will come to analyzing the request response times and so on, I will give it a short name for this kind of link. Okay, sitemap. Okay, for my first request, then I will insert after a think time. So I click here on the timer plugin line, and I see a number of instructions, like this one with the little clock here, which is a sleep instruction, so a think time instruction. So this will sleep for the 5 seconds. Okay, and I will do this for all the other URLs I'm interested in. So I can copy this one and paste here. And get the next URL. For instance, this link. And I will give another name because it's another link. I will call it recent pages, just recent, like this. Another 5-second think time. And then I can make another HTTP get with the next URL. For example, the media manager. And then another think time. I forgot to say here, the action type is media. Let's call it media. Okay, here we go with my scenario. Now, I could have done something more complex, more advanced. If you see these 4 lines here, which are not related to any plugin, they are just logical statements. So this first one is to implement an if-then-else construct. The next one is the while loop with arbitrary conditions. And these conditions are provided by the plugin that we imported. You have here a probabilistic branching. So with this instruction, you can define any number of sub-branches and put some weight on each branch. And then each branch will be executed in a probabilistic way according to the weight that you gave. And finally, you can define a preemptive condition on a behavior block, and anytime the condition will become false, you will exit from the block. I'm not going to show you for this demonstration. Okay, so the behavior is ready, and now what I have to do is to define the number of virtual users of this behavior that I want to run. For this time, what I want to do is just unit loads. So I will create a very simple load profile, saying that at time 0 seconds, so at the beginning, I want just a population of one virtual user. And then I want to execute it until, let's say, 20 seconds with still one virtual user. You see here a graphical representation of this load profile for this behavior, whose name is B0. So we see that it's just a flat unitary load profile, one virtual users for 20 seconds. What will occur is that this behavior will be executed first once, and if the load profile says that we want to go on, a new virtual user will be created at the end until the 20 seconds are reached. And then it will be completed, so we may last a little bit further than 20 seconds, because basically this a single behavior, a single virtual user should last about 15 seconds here, because there is 3 times 5 seconds lead time plus the response time of the 3 get calls. Okay, so now we are done. So for the scenario is ready. So now the other thing I have to create is to define the test plan. With the CLIF test plan, we are going to say that we want to deploy this specific scenario. So I have to add a load injector to my test plan. Okay, this is just a unique identifier. This is the place where I want to deploy this load injector. The local host, in 2 words, is a designation for the console itself. So it will be deployed within the console. We don't have to run any external CLIF server. Okay, which is convenient for when it comes to creating a new test at the beginning. And for this, I will choose the injector role, and I will choose the Isaac runner class because I have defined an Isaac scenario. And the argument is just the scenario name, file name, unitload.xis. Okay, now it's ready to run. I right click on this on the CLIF test plan, and I use the wizard test plan deployment. Okay, it's very quick here. Okay, so I save it, and I will just redeploy it. I initialize, and now it starts. So according to the load profile and the behavior, it's a normal situation that we have 1 request each 5 seconds. And it's also a normal situation that we go further than 20 seconds because the scenario must be completed before the end. Okay, we're done. I click on the collect button because I'm interested in getting the results of this test. And now in the report directory, I see here the identifier of my load injector in the test plan. And I have an action file. This action file is actually a CSV formatted file where I get a lot of information that I could import directly in a spreadsheet in a calculation sheet program. We see a lot of information. We see the kind of request. We see the URL that has been issued, the response here, okay. And here we have the response time in milliseconds. We have also a Boolean here, true, everywhere, saying that this request was successful. And here the session ID is actually the virtual user ID. So we saw that the first virtual user was run, and since it completed before the end of the load profile, a new virtual user has been created, and also performed the three requests. So as I said, you can import it in any program, business intelligence or reporting tool. You can get also a statistical report here that gives you request by request and also globally for all kinds of requests mixed. The number of calls, the minimum response time, the maximum, the average, the median, the standard deviation, the throughput, and the number of errors. Okay. We have also an embedded reporting tool. So I right-click on this project. I use the wizard whose name is Test Report with CLIF. Okay, I just click on Finish. This is by default the directory path here to the report directory for this project. Okay, I create a new data set and a new section, and I will going to get the measurements for this test execution. There is only one injector providing the action data source. I click on Next, and I'm just going to say here I'm interested in the duration field of this data source, and I click on Finish. And I have here something showing the response times of each request. There should be 6 requests. I can have, this is a time-based presentation because on the x-axis it's the execution time in milliseconds, but I could be interested also in analyzing the distributions of the response time, so I can choose an histogram, or I can choose quantile analysis. When I'm happy with this report, well, I can say, I can change here with and put some more explicit titles. But when I'm happy with the report, I just have to export the report, for example, my desktop here, and then I can find on my desktop this report. Okay, this is an HTML export, so I have it as a single web page with a description of the data source, data set, global statistic array, and the chart that has been generated. Okay, let's go back to the CLIF console, and let's do something more interesting. Let's say that we want to do a bigger load. So I'm going to copy-paste this unit load test. I'm going to call it big load. I open this scenario, and I'm going just to change the load profile. I will say that at time 0, I want 0 population. Then let's say that at time 20, I want a population of 50 virtual users. And then let's say that at time 60 seconds, 1 minute, I want still 50 virtual users. Oh, sorry, I missed something. So let's see. Okay, this is the log profile. So here we have a ramp up where we are going to introduce new virtual users, and here we have a plateau with 50 virtual users. It's important to note that each time a virtual user will complete its behavior, new virtual users will be instantiated, so that we always keep this load profile in terms of active virtual users. Okay, so this is finished, and now I'm going to copy paste the unit CTP, and I will call it big. And I'm going to edit it. So here, the scenario to deploy is big load. We're done. Now I can deploy it. Initialize the test and run it. And I will see here that I will have much more requests performed and much higher throughput. Here I go to the server, and I'm going to have a look at the logs of Apache. And we see all the requests that are actually performed on the server. So we can say that it's working all right. Okay, we see here the ramp up and the plateau at around 10 requests per second. Because we have 50 users that perform one request each 5 seconds. So it's a normal situation that we get about 10 requests per second globally. I collect the measurements, and I can have a look at quick stat file. Okay, so we got 185 calls for each request, and here are the statistical values. Okay, now let's be a little bit more in advanced things. So what I'm going to do here is that I'm going to make a distributed load test, which means that I'm going to use another load injector located on another computing node. I go there. Which is important here is that I have to right-click, go to the properties, and have a look at the network properties. By default, you will be the network address of the CLIF console will be localhost, and it's mentioned here that it's only valid with a test plan without remote CLIF server. Here we need to have a remote CLIF server, so we have to have this the local IP, the public IP of this laptop I'm working on, and I will have to give it. You have to restart also. Here I don't need it because it was already configured like this. So I have to go to my remote CLIF server here. So this is the CLIF server distribution that you can download in the same way. And this runtime is operating system independent. So you just have one to get, and it works on all platforms. And here I have to say, before running my CLIF server, where is the CLIF console? So I type this command, /test equals, and I have to copy the IP address, config. And now I just have to run my CLIF server, giving it an arbitrary name, just like server 2. And now if I'm going back here, I'm going to copy paste this one, paste. We'll call it double. And I just have to copy this load injector and to make another one, to paste it. I go there and I say here, I refresh the list of servers and I can choose server 2. And you see here in the tree representation of the test plan that I have 2 load injection nodes, which will do exactly the same thing, executing the big load.xcs scenario. So I don't have to create any new scenario. I just have to deploy this double. And to initialize and execute. I can monitor also the number of requests. Here we see a red line, but there is also a blue line. So you can, if you, but they are just the same, so it's not easy to see both. So I can disable the red one so that we can see the blue one, but they are equivalent. These are the 2 load injectors. Okay, so we can see the throughput, which is about 10 for each load injector. I can suspend also the execution if I want to see what's happening when I stop, or when if you need to unplug something in the network, you can resume the execution. As an advanced usage, I could also click on the parameters of one load injector and change the number of virtual users. For instance, let's say I want 100 on this one. Okay, I can stop this before the end. I collect measurements and I can do a report. This one, double. And now I can do something advanced. Since I have 2 load injectors, I want to combine the request, the measurements from both. So I can do an aggregate data set. I can choose both of them. Still analyzing the duration, which is the request response time. Here we go. We see there the perturbation, the disturbance introduced when I change the number of virtual users. And we can see here the interruption when I suspended the test execution. In the draw options, I can get more than this. I can get all the moving statistics. The minimum, maximum, the average, the median, the standard deviation, and the throughput. Okay, we get a lot of information. And I can disable the raw values to get only the moving statistics. Okay, now let's just finish with the use of probes. I'm going to modify this test plan double and add some probes. So I clicked on the edit sub-tab here, and I can change my test plan. So I will add something, but something that is of the probe kind. And well, here server 2 is the Eclipse server that is on my system under test. So I can deploy, for instance, a CPU probe to observe the consumption of CPU. And I have just 2 parameters to give, the polling period in milliseconds and the execution time in seconds. So I will say that each second I want a measurement of CPU usage. And since my test plan, my scenario lasts for 60 seconds, I will also use 60 seconds here. Okay, I can also put something more interesting. For example, the network usage. So still a probe with a network. So here, the network, I have to give same kinds of arguments. So the polling period and the execution duration. But I have also to provide the network interface identification. There are a number of ways to do that, but what I have to do is to know which interfaces are available. I have a new tool here in this latest version of CLIF, which makes it possible to have all this information. So I want to get information to deploy a network probe. So I have the choice here. I can set the interface name, ETH0 here, or the IP address, or the interface description. Well, here I have a Linux server, so the description and the interface name is the same. But under Windows, we can see that we have other kinds of description. So this will be the available interface if I wanted to deploy on my CLIF console some probes, some network probe. But here I'm going just to set ETH0. Okay, what I can do also is to check that my load injectors are performing all right. And to do this, I can deploy two probes of the kind GVM with the same arguments. One here, so this one, I want to move here, and this one. Okay, so I have one injector here with a GVM probe, and one injector here with a GVM probe, and also a CPU probe, and then a web probe on node server. Well, here, of course, the load injector for convenience is installed on the server under test, but it's not a good practice for real tests, of course. You should have a third node. Okay, now I'll just deploy it and start. So here I see that I have more tabs in the monitoring view because I have the tabs for the probes. So for this, it's the same principle as the load injector tab, but you have different metrics. Here for the free memory, use memory in the virtual machine, in the Java virtual machine of the load injectors. So each time it's increasing, it means that a garbage collection has been performed. And I have a tab for the CPU usage. Here it's on the system under test. For the load injection, I can see the number of requests. Okay, all is performing all right. With let's have a look at the average response time. So we see here a difference in the average response times, just because the blue line is the line for the injector that is co-located with the server. So of course there is less latency. And we can see also here on the network probe that the traffic has been increasing on the system under test. Here we have also an alarm tab where we can see each time the garbage collector has been run on the load injectors. Okay, the test is completed. I collect, and I can have a look, for example, at the quick stats. The interesting thing here is that I have several load injectors, and all have been aggregated among all load injectors. So it's already an aggregation. I don't have to add. Okay, so we have all the same values. And if I go to, if I want to use the test report tool, I will find this execution, and I will show you something interesting. It's the multiple dataset type, because here I have a number of probes of the same kind, GVM. So GVM here and GVM this one. So I can do a multiple dataset. It won't be an aggregation, but just doing the same analysis on from both data sources. Okay, so we have the two graphs on the same part. I didn't show you, but you have statistics or global statistics here that are generated. Okay, so I have shown you, I've demonstrated the latest version, CLIF 2.2.1. We have been improving user experience and also documentation. Probes have been fully implemented. They are based now on a living and mature project, which is always popular. It's the CIGAR library. We have more operating systems supported by these probes and more metrics. And now we have released this first version, this first stable release of the embedded analysis and reporting tool, and we'll add more features in the next releases because we think it's an important part of the job of load testing. And I invite you to meet us at the Paris OpenStack Summit in 2 weeks, where we'll be giving a talk about deploying load test in continuous integration over a cloud. I thank you for your interest in CLIF. Thank you.